It's a Saturday afternoon. You're relaxing at your home, and suddenly you get a call from your friend. Hey, finally, Martians are here. Tell me more about them. As you start to answer, you start seeing that your email is blowing up, your text is blowing up, you have 5 calls waiting. What do you do? There's an information overload. Everybody wants to know about Martians, and you are the foremost authority on Martians. How do you tackle all this information? You want to parallelize this, and the best way to do that is to build a bot. So, you want to build a bot which will be able to answer the questions that are coming in from a lot of random people. So, there's going to be a lot of queries against the dataset that you hold. Interestingly enough, the information will be rapidly evolving. Where is Martian Man right now? What color is he? Details like that will be evolving over time and might also become stale fast. There's also a temporal nature of this because you know that Martian Man is a myth. There is no Martian Man. It could be probably some teenager in a green suit somewhere. So you don't want to do a lot of engineering work to build this bot. So what do you do? There's a lot of temptations here. You could train a new model on all of the data that you have. You could train a model, take an open source model and fine tune that model. You could also just make all of your data open, but you don't really want to do that. There's a lot of random data in there. It might take a lot of work to make that data openly available. Or you could go with option 4, which is you load up everything into system context. If you load up everything into a system context, that might make the model slow because there's a lot of information available. And then every time users are querying, that system context will need to be passed to any end model that you are using, and that will make the request slow, and everything will become slow and slow. So, what do you do? Well, we have context caching from Gemini team. Let's dig deeper into what does it actually mean and how can you start using it today. So to set it up, we will do the same thing as before, where we'll get our API key from Google AI Studio, and then we'll set up our SDK. Nothing changes here for both of these steps. Now we will do retrieval. So in this case, we are going to download our video file. For this example, we are going with a sample video that Google team has provided us here, but this could easily be your data set. Now this video, since it's provided by Google and probably a lot of other people are also using it, it downloaded in 1.82 seconds. But for your data, it might be on a hard drive, it might be on different locations, so it might take much more longer than this. So remember, this is a cost to download your data so that it's ready for being uploaded into the model itself. So we download the file, we upload the file to our Gen AI model. I'm timing all of these, so we have the total time that it takes to upload this file. This is a nice API here to check if the file has been uploaded properly or not. So we are waiting for video to be processed, and once it finishes uploading, it's available here, and the wait time is 27 seconds. Note that this video itself gets deleted after 48 hours automatically, or you can make a request to delete this video. So now that the video is uploaded, what you could do is you could just directly go in with a non-cached example where you take in the video that you're passing in, the video file, and you can start running. This is the example that we talked about here, where you load up everything into the system context. So this is our system context, in this case, the video file, and our prompt, generate a summary of the movie, and we load everything into the model and we ask it to generate content. So it generated the content. I'm not showing that, it's not important, but what you can see here is it took a lot of prompts in here, 696,000 prompt tokens in the prompt. It only generated 65 words at 65 tokens at the end on the response, and the total token count is this. It took a lot of time, 48 seconds to generate this. But remember, this time is nothing in comparison to the time it will take you to download the file and then again upload this file to GenAI Studio or GenAI in this GenAI API. Now, how do you make this better? So we go to the caching part. The way you cache it is you just call this another function that is available within GenAI Studio, GenAI API package, which is caching, and you call it to create a new cached content. In this case, I'm not passing any TTL. I'm passing TTL for 5 minutes, which is also default. But you can change this to hours, days. You know that the fad for a Martian man will die in 10 days. So you set up the TTL to be 10 days. You give it a name that will be used to identify the cache. And then, of course, you can give it more system instructions on top of it, along with the content that you want to cache. So this whole section will get cached. So remember, there is not only the system instructions that you're caching, but also the contents of the video itself. This took 50 seconds to cache the whole thing. Now you can start using this cached. You generate a model on top of this. So that's the best way to think about this. Essentially, when you use caching, what Google is doing is giving you a new model, which is temporarily lightly tuned on your data. And that model is the one that you end up using for caching in here. That is the new model essentially. So this is your model based upon this data file that you provided, the cached model. Now you can generate content on this model. So we asked the model to generate something in here, and it took 51 seconds to get the response out. And the best way to understand whether it used any of the cached value or cached content or not, you can see here there is a cached content token count in here, which was this many tokens were totally used from the cache itself. You can keep making more queries on top of it until the 5 minutes expire, at which the TTL will be lost. You can also upgrade this TTL as you go through. So let's say you started with 5 minutes, but then you realize there's a lot of requests coming in. So you can update this TTL to even more. So that's how you would use it. Now to calculations. How would you calculate the time or energy that you're saving in this? The way I like to think about it is you have 2 seconds to retrieve the file. Excuse me. 51 seconds to cache the file once with a long TTL. You can update this before expiration. And then 43 seconds for each query. And on here, we have 49 seconds for each query on the non-cached model. And this 27 seconds for uploading the file every 48 hours will happen as well. It doesn't seem like a lot, but depending upon your use case, it might actually be a lot. So let's actually go talk a bit about use cases. So how do you start thinking about when to use caching versus when to not use caching? One of the easiest ways to think about this is high frequency and high retrieval cost. This is true for all sorts of caching, whether it's a database caching layer that you are adding, or in our case, a Gemini-based a caching layer where context caching within the GenAI model itself. So what you're looking for is the cost and latency of generating the embeddings and then retrieval itself. And then of course you're looking at how many calls are happening on that same data. So that what you are doing is you're saving. If the retrieval cost is high, but there's only low frequency of requests coming in, then it's fine. You probably will not save anything because there's a cost involved with storing the cache as well. But if you have a high retrieval cost and high frequency of usage, then you definitely can use caching in here. And this caching will allow you to make the model go faster and work faster. Some of the use cases that I'm thinking about, maybe you have better examples. Some of the examples that I have is agentic use cases where you have a auto ML agent where it automatically tries to figure out AutoGen agent, AutoML agent, AutoGen agent, which is using the context as it's going through the processes to trying to figure out what can it do, what should it be doing. So there's a big base prompt, and there's an evolving prompt on top of that, with which it's running multiple agent processes. So in this case, there's going to be one big model on which it's going to be doing multiple calls back and forth. And you don't want to use something like a RAG here because it will be kind of costly because you're going to be making a lot of calls to retrieve that data. And there would be a code repo analysis where the base data set does not change much. So you have a complete code repo and you're trying to ask a lot of questions on top of it to ask for like which library should I be using? Can you find any vulnerabilities in here? Can you write tests for certain things in here? So all of those would be repo analysis kind of use cases where the main big chunk of your context, which is the source code, does not change often. Another fun example that I was thinking about this was a game book in a narrative gameplay, where you could take a complete Dungeons and Dragons kind of book in and Dungeons and Dragons notebook, and then the whole gameplay goes into the model. The whole thing is in the context, and then as you are playing games, it's using that context to drive the story, to drive the whole narrative, and helps the gameplay become better. And you don't have to worry about fine tuning a model or loading a lot of context into the model, retrieving through RAG and stuff like that. In short, what you're going for is something, if something has a very long context, then you can start using context caching for it. But remember, just not very long context. You're also looking for high frequency usage. Okay. So the best way I like to think about this is it's a temporary model which has your context. So temporary model because it gives you a TTL in there, you can delete it. If the information becomes stale, information becomes incorrect, you can totally spin up a new model and remove the older model that you have set with a lower TTL. And it has your context. So you don't have to worry about retraining a new model. You can just use this model for your use case. It's a temporary model. I'm really curious to see how you will be building more with context caching. And if you have really good examples, please share those with me. I might make a new video around how to use context caching in a real world example. So yeah, looking forward to that. All right. Have a great rest of the day and enjoy your evening nap. Hopefully no Martians come to disturb you. Have a good day.